Welcome to the DD1324 online lectures. In this lesson, we'll go over the calculator example that we worked in the previous lesson and generate the source code. Okay, so let's begin by starting to write the calc.c, the main file for the calculator program. We'll begin with an include stdio.h and then the standard library. And now we're going to start including some of our own custom written header files. So instead of enclosing them with these angled braces here, we're going to use double quotes. That means we've written it ourselves. So the compiler should look locally for them. So we have display.h, exponential.h, and arithmetic.h. Next, we're going to define a global variable. We'll call it result. This is where we're going to store the result of our calculator. And something important to note is that the other files are going to have to use the extern keyword to access this global variable. Access it. Okay, so yeah, so actually let's move over very quickly then to make a file called calc.h, and in this file we're going to use the extern keyword so that other files can access the global variable. So what we'll say is extern double result, and so when we say this, so this file we'll call calc.h, and when we say extern double result, that means that we're promising that some other file defined result. The next thing we're going to do quickly is to do what's called guarding in a header file, where we're going to put some conditional compilation directives for the preprocessor that make sure the header file is only included once during compilation. So we put a keyword called if and def. So that means if not defined, and then we're going to call a variable, we'll call it calc. So if calc is not defined, then we will define calc, and then we will make we'll declare this double extern result, and then we'll say end if. So what this is doing is anytime any of the other files say include calc.h, it's going to run all of this code. First it'll say look and see if calc is already defined. If it is, then it'll skip to the end. But if it's not defined, it will define calc, and it will declare this external variable result, which we give a value here in calc.c, and then it closes the end if. Okay, so now we can go back to the main file, and we can continue. So we'll create our main function, and we'll have argc and char argv as inputs. And now within the main function, we're going to create a couple of variables. We'll make a float for operand A and a float for operand B, and then we'll create a char for the operator. And now we're going to do a sanity check with the arguments. So we're going to say if argc is not equal to 4, then we will complain to the user. We expected 3 arguments, for example, /calc 4 plus 5. So this is basically complaining in case they give an improper number of arguments. So now let's convert the arguments into floats. So we'll say convert to floats, and we'll say operand A is equal to a to f of argv of 1. So this is coming from the C standard library. It converts one of the argument strings into a float, and then we have a to f of argv of 3. So arguments 1 and 3 we want to convert into operand A and B, and then we want to get the operator as a char. So we'll say operator is equal to star argv of 2. And so this will give us the a char from the string. Okay, so next let's make a switch statement, and we'll switch between all the different operations that we see that were given by the command line. And each of these operations will call a function from one of the other modules, like the arithmetic module or the exponential module. So first, let's see, we have the case of addition. So in this case, we'll call a function that we'll define in the arithmetic in the arithmetic.h. We'll call it addition of op A and op B, and then we'll break. And if we have subtraction, we'll do the same thing. And for division, for multiplication, we'll use an X instead of a star. And then we'll do exponentiation. Up A, up B. And then finally we'll make a default. So the default will check and make sure that we were passed a valid operator. So if we didn't find one of those cases, then we didn't have a valid operator for the second argument. Okay. So that's our switch statement. Now we can make a we can use the external module for printing. We'll define a function called display result, and we'll give it op A, op B, and the operator. And it also will have access to the global variable. And then last thing we'll do is we'll return 0. And that should do it for calc.c and calc.h. Oh wait, actually we have to correct this. This should be operator, not operation. Okay. Okay, so next let's go and start defining the arithmetic operations. So we'll go to arith.h. So we're going to put our guards just like before. This time we'll have if and def arith, and then we'll define arith, and then we put a and if. Okay, and now inside of this header file we need to put our function prototypes. Prototypes. So we'll have void addition, and it'll take a double A and a double B. Void subtraction, it'll take a double A and a double B. Void division, a double A and a double B. And void multiplication, double A and a double B. We can copy and paste these function prototypes now. So when we go to arithmetic.c, we can paste those in here because we'll use them again. So now in arithmetic.c we have to start with our includes. So we do include stdio.h, and we'll include arith.h, so the h file for this one, and we'll also include calc.h, which, if you remember, that's defining our external global variable. So now we can start to write our functions. So now we don't want to suppress the output for each of these functions. So we take away our semicolon, or not suppress the output, but we don't want the semicolons to end these statements. These are definitions. Okay, and so addition is simple. Result is equal to A plus B. Subtraction, result is equal to A minus B. Division, result is equal to A over B. And multiplication, result is equal to A times B. Good. We can go to the terminal quickly and check and see if this arithmetic function that we just defined compiles. GCC minus C arith.c, and we can see that it compiles. So now we have an object file, arith.o. So next we can define the exponential header. So we can say, once again, we'll put in the guards, if and def, we'll call it exp, define exp, and then end if. And then here we'll only have one function, and it'll be exponentiation of double of A, double of B, and a semicolon at the end of that. So now we can go to exp of C. So the .c file, we'll do an include stdio.h, and we'll include math.h this time. We'll also include our own header file, exp.h, and we'll include calc.h, which, oops, these should be with double quotes. Calc.h. So, and calc.h has the external global variable. And now we'll make a function definition. So we'll only have to define exponentiation. So void exponentiation of double A, double B. And now inside the math library we have the function pow, so we can say result is equal to pow of A comma B. And this will compute the exponent of A raised to the B power. So now the last header file that we have to define is the disp.h, the display. So we'll start with if not defined display, then we'll define display. And here we can make our declaration. We'll just have one function for for this module. We'll call it display result, and it'll take a double, another double, so the two operands, and then also a char for the operator. So we're also going to print out the operator, and then we put the end if. And now, did I save it? Yeah, I saved it. Okay, now we can write the .c file. So we do include stdio.h, and now we'll include the disp.h. Oh, sorry. Include disp.h, and then we'll include calc.h. Now I can say void display result, and it takes a double, another double, and the operator. Oh. And now we'll do a couple printf commands. So performing calculation, and then we'll say printf. So we'll give first the first operand. So we'll say %f/n, and then a, and then we'll print the next operand with the operator. And then we'll print a kind of a new line here to show the result, and then we'll say %f and the result. Great. So now we've written all of our files. Let's go to the terminal and see if we can compile. So gcc calc.c, arith.c, exp.c, disp.c -out calc. Oh, we have it looks like I misspelled print or printf in the calc.c file. Yeah, here. Okay, so we save that, and let's try going back to the terminal now. Compile again. And it compiles. That's great. So now we can calculate, let's say 2 to the 3, or we can calculate 5 times 2, or we can calculate 100 over 4. Yep. So that's great. So now you can see how you can break up one large program into multiple files, and you can define each of the headers, and you can make sure you have global variables working between all the files, and that how you can compile them as well. This concludes our example on the multi-file projects with header files in the preprocessor. Thank you for watching.